Good day, everyone. My name is Sarveshwaran Ananaki Balakrishnan. My metric number is GS66856. Today, I'm going to present about my product innovation for the cost engineering product design and innovation. Uh, anyway, good day to Dr. Zuri and my fellow friends. Okay, let's start. So, in this slide, we have like a few sections as stated here. So, let's start with introduction. So my innovation for this assignment is a smart outdoor drying system. Actually, what is smart outdoor drying system? It's like everyone knows, like we in Malaysia usually we dry our clothes in the outdoor mostly, and sometimes we have a dryer inside our home. So, as a Malaysian, we know that our weather sometimes rain, sometimes sunny. So we really cannot predict the weather. So we need a solution when we want to dry the clothes outdoor. We need a solution for this because the weather is unpredictable. So that's why I'm here to suggest the product Smart Outdoor Drying System to save our time, energy, and everything from our busy schedule. So this is the market investigation I have done. So from here we can see the market research, which is laundry market. In Statistica market forecast, they have predicted the growth of the market is likely to about 3.7.4 percentage annually between 2023 and 2028. That's a very huge market. It's going to grow. So they have predicted to generate a revenue worth US dollar 1.09 billion by 2023. So this is the market research I've done on based on the statistic on laundry. So the target market for our product, which is the smart drying system, is around age 25 to 55. Actually, why I choose this age is like basically assumption of age where like mostly we will be employed working, we might have a busy schedule. So I have done a research. The population of Malaysia age group 15 to 64 age is 23 million. This is on 2023. Actually, in this statistic, they have provided the range 15 to 64. Actually, my target market is 25 to 55. So from this data, and I have found that 16.06 million individuals in Malaysia are employed. So employed means they have like a really working and busy schedule. We can assume that as a Malaysian, we know we can assume that. So next, I have done SWOT analysis on this product. So first strength, our product is going to have an innovative technology, which is a smart system, and it's gonna be a time saving and effective. So it gonna save your laundry time, and you don't need to wait and predict the weather, all those stuff, and the process gonna be effective because sometimes we will let the clothes will get into rain and we can't do anything. So this will be effective and we'll have an eco-friendly and energy efficient system. So in typical dryers, like instead of outdoor dryer, the indoor dryers, they need a lot of electrical consumption. So by outdoor drying method, we can save this energy and make the system is more efficient. So we'll have this system will have weather adaptability, so it can predict the weather and react based on that. So next, I'll go to the weakness of the product. The weakness of the product is basically costing. So because we are going to integrate a lot of technology things and sensors and all those like mechanical stuff, which will cost much higher compared to the uh, existing product. So next is reliance on mobile phone. We're gonna have a software for to control this system. So if people don't have the mobile phone, which is a rare scenario, but they will face a hard in controlling this system. So next is threats. So we'll have legal and regulatory consideration like safety and all the regulatory requirements, and also IP protection, and also competition from existing suppliers who have like already in the market for a long time, and economic factors because sometimes we didn't predict COVID. So sometimes when this kind of things happens, we won't spend in other like extraordinary things, and we'll stick to the old style, which is much more cost saving. So these are the threats. Next, I'll move on to the opportunities. So the opportunities, as I mentioned earlier, the growing market demand for the laundry system, and also environmental awareness, and also technology developments. So basically now they are encouraging this green go green stuff, and although like technological stuff which like a trend is which is industrial industry 4.0. So next, I'll go to the concept development of this product. So we have 5 stages, 5 concepts. One is a mobile application control, which I mentioned earlier. So we'll have a mobile application control to control the system, and we need to have a concept of energy efficiency, which like consume less power, less energy compared to the existing product. And auto shade adjustment, which is important, like when it's raining, it should find the shelter to protect the clothes from raining. And also weather monitoring system. We will have a sensors which monitor the weather system outdoor, although we are not there. And we'll also have the final concept, which is a customized drying programs. These programs will be like pre-programmed in the product itself. So like when we are not reacting, or we didn't notice something or notification or what, they will react based on the customized program. And also we can program based on the clothes, because all the clothes they have a special characteristic of drying. Next, I'll move on to the concept evaluation. So for concept evaluation, we need to have a existing product to compare with our product. So here I have chosen 2 reference item. I'm very sure you have seen in this system in your home, like maybe sometimes you might have the reference item one, which is a wall mounted retractable clothes rack, and sometimes you might have like reference item 2, which is a foldable clothes rack. So this is the path matrix. So we have a criteria, which is a space saving design, installation, ease, mobility, weather monitoring and control, material, payload, power source, cost and durability, all those criteria. And the reference item. So we'll have the, as mentioned earlier, the reference item 1 and reference item 2. So here we have going to compare with our smart drying system. So these are the comparison, as we can see, with the reference item 1 and 2. So based on this, we're gonna give weight for the criteria. After giving the weight, we have like came to a conclusion that our smart drying system outstand with the existing product in few criteria, especially space saving design, the payload gonna be more, and the mobility, like it's gonna be a mechanized mobility, and the power source. So basically it will have a power source advantage compared to the other 2 reference item, which you need to be controlled by manual. And also we have a weather monitoring system, and the product we're gonna create is a high durability. So these are 6 criteria. Our smart drying system, it's already eliminated the existing product, but we have to notice that the reference item one is low cost compared to our product, and reference item 2 is much more lower cost. So the costing is an issue in this park matrix, but we can consider other advantages, the 6 criteria which we outstand. So these are the detailed design. As we can see, like we have a controller which is a Arduino Nano, and we'll have like sensors BME 280 sensor for the temperature, humidity sensor, and rain sensor to detect the rain. And we'll have a battery supply for the system, and step down for the all those like controller unit which need like less power. We're gonna have a battery like 24 voltage. So some devices use directly 24 voltage, some devices use less. So we're gonna have some step downs for the devices that use less, and direct for the devices that use exactly 24. So we'll have mechanized physical elements like a motor driver, actuator, direct current motor, and also like the drying rack. So this is our program flow chart. So we'll have a start program. The rack will extend. So it will detect like raining or humidity. If yes, the rack will retract back and find the shelter. If no, the rack will extend and start the drying process. So this is the 3D model I've created for our product. So basically we can see we have a DC motor with chain system, actuator to control the movement, and hinge where we're gonna hinge our product, like it will have like a rotational movement, and we have a drying rack, cloth hanger point, and electrical box which basically power supply system, electrical system, all those stuff, and we'll have a sensor box. Basically the sensor box is just kept there, but it might kept somewhere else, because from the sensor box we need just data like raining or not, humidity, temperature, so it's better to be exposed. And all these mechanized mechanisms, they tend to like prone to like these environment temperature changes, so like we need to have another solution for that. That doesn't detail, we provide detail in this, but we'll have a system to protect them from environments. So next, we'll see the working principle. So as we can see, this is the initial position. So then once we want to start the cloth hanging process, which is the first, so we will tell the system we need to start the process. So you will come down straight to us. So then we need to decrease the drying rack height, because like somehow we need to keep it as far as high from us, so we have more space. So once we put it straight, we need to like pull down the drying rack system using software. This one everything software. So once we have those things, once we finish hanging the clothes, we put back the drying rack into the slot. So wait, okay, we put back, the actuator will pull back. So once the actuator pull back, then we'll have like next step, which is drying step. So our motor, we can see the DC motor located behind, will use a chain system to use a rotational movement and move the drying rack towards outdoor. So it will like move, use the sprocket, the chain system. So once it like move outdoor ready, then we'll like set, okay, the actuator will like push the drying rack outside furthermore to the outdoor, so it will be like more exposed to the sun. So we can see it's moving outward. So this is a slot system, so we'll have a slot like for the actuator like pull and move the drying rack. So we can see the actuator located on top, and we have a DC motor behind the hinge. So this is the completed stuff. So then we'll have the next process of our product, which is a manufacturing process. In this, we have 6 stages. So first, we need to have a design implementation, as like we need to like provide the technical drawing and all those stuff, where we're going to mount, where we're going to put the place the sensor, all those stuff. Then the second stage is component sourcing. So basically, in designing, we need a component sourcing. Like we will use a standard parts existing in a market to reduce our cost instead of a custom made. So as we can see, we will use like sensors like Arduino Nano controller, a BME 280 sensor, display and LiPo battery, motor driver, actuator, DC motor. Everything is a standard part from markets. After that, we'll have an assembly process. We'll assemble everything. Then we'll have a software development. So we need to flash the Arduino Nano, give the input. We'll write the code, so we can test. Is it like really collecting the temperature, humidity, and rain data? It's reacting. Is it correct, accurate? Then all those stuff, we'll develop a mobile application for this system, so we can control from our mobile instead of like depending solely on the controller. So then we'll have a quality control. Obviously we need to check our quality, product quality, so we'll have a quality control check each component, is it okay or functioning based on what we need. and finally we'll have a prototype testing of our product. So the conclusion is like this product is just a prototype, but a suggestion, and this is a, like a outstanding innovation. Not to say outstanding innovation, like a good development of current existing product which they use as like the reference item 1, reference item 2. So this we can see the product can like uh, will be a big breakthrough if it launch in the market. But as also we need to determine like more. The first thing is like we need to collect the feedback from customers because they are very important and they are going to use. So the feedback from they is very important. We never collected the customer preference, so we will do like a surveys checklist or everything to collect the from the customer point of view. So that's important. So we might have a iteration from this product because like we obviously need a cut costs and all those stuff. So the system will have a mobile monitoring system which like will attract more interest from everyone, and I think it will be a like a good product and will attract many customer. And forget to mention, so the iteration could be like the DC motor we can use something like more powerful because we don't know the application and the payload from what they prefer. So the DC motor, the actuator, and basically even the drying rack. Here I have made a solid bar, but actually it could be like a scissor bar which can like foldable also. So this is for prototype, just for illustration, and this model is not scale to drawing, it's just illustration. So that's all from me. Thank you.